Hi everyone, hope you're well. This is just a quick tutorial just to show you how to use the Steel University Charpy Testing Simulator. Just a word on Steel University, it's a really good website, it's really good resources on there. I do recommend that you sign up to it using your college email, things like that, but it will be really good for you to use. Got lots of resources that you can use on there, particularly for materials. Okay, so click Start at the bottom. This should be the website that you come up to. So as you can see now, you've got the actual test simulator. This is a test rig. We've seen this previously in some YouTube videos that I've uploaded to the Canvas pages. You've also got the sort of water bath here with the sample just located in the middle. This is a metal sample that we're going to test. Okay, we're going to place it into this vise. This vise is just an exploded view of what would originally be down here. It just shows the illustration of what it looks like. Right, so on the right hand side we've got a tab, and on this tab this can allow you to set your parameters. So really what you want to do is just set your temperature, and it's a temperature versus energy graph that we're looking at. Just be aware that we can only go to a maximum of 80 degrees centigrade and a minimum of minus 120 degrees centigrade. I will give you the list of temperatures just to set them as you can. So just as an example, just something to look out for, you can type in your numbers by the way, or you can just use this up and down key. Let's just set a temperature of 16 degrees. Now, one thing to be aware of, you'll see that this is now heating up to 16 degrees from 0 or whatever. As soon as you take that sample out and load it into this vise, naturally the air is going to warm or cool this sample down. So the longer you leave it before you actually strike it with the hammer, the sort of validity of the test is going to become less accurate, let's say. So then you need to centralize it, and then you need to raise the hammer. Now I'm taking a long time here, so this is not going to be accurate. So I've reset the hammer, I close that, I click Start, and you can see there that because I took too long, the specimen temperature is no longer accurate. It's, naturally tried to get closer to maybe 20 degrees room temperature, something like that, so it's not accurate. So what I'm going to do is just restart the test, just clicking the refresh button at the top. So the first thing that I'd like to do is I'm going to reset the hammer. Okay, I'm ready there now with that ready to strike. I'm going to then set the temperature. Let's say we're going to do that 16 degrees, whatever. Okay, we'll let it warm up to 16 degrees. Then I'm going to load it in, centralize the specimen, and then start my test. Okay, so now we have an accurate reading. We've got 16 degrees, it's still at 16 degrees, and you can see there the needle is at 112 joules of energy. So that's how much energy was absorbed by the material, that specimen. You'll also see here you've also got a point now on the graph. You don't have to read the axes. You can see there is 16 degrees or there or thereabouts, and you'll see that you've got a reading of 112 joules of energy absorbed. So we're going to do a couple of these. We'll do a minus 16 just to give you an example. So we'll set that to minus 16, let it cool down. We'll close this. It's at minus 16 now, so the sample in the bath is at minus 16. Click that, centralize it, start. It's accurate again, there's no issues there, and now we have an energy of 60. Okay, so what was it originally? 112, and we now came down to 60. So you get two plots pointed. So I'm going to give you a few of these to do. You're going to record them, and then we're going to write a little report on why that is, what we found, and investigate that as well. Okay, thanks very much. Bye now.